A pharmacist wants to produce a 5% benzoyl peroxide cream to help a patient treat their acne. They have a supply of 2% benzoyl peroxide cream and a supply of 10% benzoyl peroxide cream. How much of each cream should they mix to create 80 grams of 5% benzoyl peroxide cream? In this case, when they ask how much of each cream should they mix, they mean the 2% cream and the 10% cream. Those are the two that they have a supply of that they're trying to mix to produce a 5% cream. So those will be represented by our variables. Let's let the amount of 2% cream be X, and let's let the amount of 10% cream be Y. Now again, this is a mixture problem, so when we set up our table, we're going to need an extra row because we're starting with 2 creams, and when we mix them together, we'll end up with a third, so we need that third row. Labeling our columns will be solution, concentration, and ingredient. And the relationship is solution times concentration equals ingredient, just like before. On the left-hand side, we'll label our rows with the different creams that are used. The 2 creams that are getting mixed that they already have are the 2% cream and the 10% cream. And when they mix them together, the goal is to end up with a 5% cream. Now let's start filling in the information. The amount of the solution that's 2% cream is X, and the 10% cream is Y. Those come from our let statements. When we mix them together, we're told that we want 80 grams of the 5% cream, so that third entry is going to be 80. The concentrations are just the percents converted to decimals. 2% is 0.02. 10% is 0.1 or 0.10. We don't need that extra 0. And then the 5% is 0.05. And just like all of the other problems that we've dealt with tables, we need to multiply the entries in the first 2 columns to get the third column. So to get the ingredient, we multiply solution times concentration. When we do that, we end up with 0.02x, 0.1y, and 80 times 0.05 is just 4. At this point, we need to write a system of equations that models the situation. The first equation will come from the solution column. X plus y equals 80, because we have X grams of the 2% cream and Y grams of the 10% cream, and when we mix them together, we want the total amount to be 80 grams. So X plus Y has to equal 80. The second equation will come from the ingredient column, and that's going to be 0.02x plus 0.1y equals 4. And again, we're going to solve via substitution. In this problem, I'm going to isolate x first. To do that, I'm going to subtract y from both sides of the equation, giving me x equals 80 minus y. And once I've done that, I know what to do for my substitution. We know that x is equal to 80 minus y, so wherever we see an x in the other equation, we can replace it with 80 minus y. Let's make that substitution. we end up with 0.02 times, and instead of x, we have 80 minus y, then plus the 0.1 y equals 4. We need to distribute the 0.02. 0.02 times 80 is 1.6. So this gives us 1.6 minus 0.02y plus 0.1y equals 4. At this point, we can combine like terms on the left-hand side. Negative 0.02y plus 0.1y is equal to 0.08y. And then we have plus the 1.6, and that still equals 4. If we subtract 1.6 from both sides, that leaves us with the 0.08y on the left, and 4 minus 1.6 is 2.4 on the right. And if we divide both sides by 0.08, that gives us y equals 30. So we go back up to our let statements, and we see that y represented the amount of the 10% cream. In this case, that's 30, and this is measured in grams, so 30 grams. We can find x by subtracting. We know that we need 80 grams in total. If 30 grams are of the 10% cream, that means that the other 50 grams, 80 minus 30 is 50, have to be of the 2% cream. We can also find this via substitution. X is 80 minus y, but we solved for y. Y is 30, so we have 80 minus 30, and 80 minus 30 is 50. So to state our conclusion, they asked how much of each cream should they mix. They should mix 50 grams of the 2% cream and 30 grams of the 10% cream. And that is our final answer.